I'm going to start working Physics Paper 1, 2019, Question 1. The speed of ocean waves having wavelength lambda in deep waters can be approximated by the expression V equals K G to the P lambda to the Q. Write down base units of V, G and lambda. Okay, so velocity, meters per second, G is acceleration of gravity, meters per second squared, lambda, wavelength, so that's meters. Show that the equation is homogeneously correct, K has no units. So we've got V equals K G to the P lambda to the Q. K has no units, so we can get rid of it. Left hand side is velocity, which is meters per second. Right hand side, we've got acceleration, which is meters per second squared to the power of P, and lambda, which is meters to the power of Q. Those must be equal to meters per second, to be like that. If I put P equals 1, Q equals 1, we won't have much luck because we will have m on s squared to the power of 1, m to the power of 1, which is meter squared on second squared. That is wrong, so I can't take P to be 1 and Q equals 1, so I'll try, since I see that meters per second squared is the same as meters per second, but you have to square root it. So we'll take square root of 1 in both cases. So we'll try P equals half, Q equals 1/2, and that will be meters over second squared to the power of half, where I've got G to the power of P, and Q, like lambda to the power of Q, will be m to the power of 1/2. Combining them together, I've got meter to the half plus half at the top, second squared to the 1/2 at the bottom. We get meters at the top because of these we add them up, and at the bottom, second squared to the power of 1/2 is seconds, and that is the same as what we had over here. So we can say that is, therefore, the equation is homogeneous. Now, part B. A ship travels in a course due east with a speed of 20 meters per second. So this means that we have a ship traveling in this direction at 20 meters per second. It is supposed to travel, of course, in a direction that is 10 degrees south of east. So this is going to be in this direction, 10 degrees south of east at a velocity of 20 meters per second. That is due to the waves, due to the increased speed of the wave. Distinguish between speed and velocity should be simple enough. You just say that speed is rate of change of distance, while velocity, rate of change of displacement. Then, part 2, calculate the combined velocity of the wind and water currents. Angle of velocity vector also should be given. To work this out, we have to form a right angle triangle with what we have over here. Draw the components of this one, and also components of the other one horizontal. Here I've got 22 cosine 10, and here 22 sine 10 degrees. I can form another triangle. Horizontally, we've got 20 meters per second plus 22 cosine 10, while vertically, which I can write down over here, I've got 22 sine 10 degrees. And from there, we've got to find the velocity resultant, which is at angle theta. You continue by using the Pythagoras theorem. Horizontal vector works out to be 3.82, and the vertical vector works out, both of these work out to be 41.7. Velocity squared, then by using Pythagoras, equals 41.7 squared plus 3.82 squared. So velocity will square root of the answer, and it's equal to 41.87 meters per second. Angle, you can use tangent theta, opposite on adjacent. Opposite is 3.82. Adjacent is 41.7. And that means that tan theta will be equal to 5.2 degrees.